When is the water pump current at its peak?
At zero speed, precisely at the moment of startup.
How big is the current at that moment?
Depending on the pump's model, it could be 5 to 10 times the normal operating current.
Why does such high current happen?
If the pump uses a brushed model, at startup, the rotor hasn't started spinning it, so there is no back EMF from the windings to offset some of the supply voltage. At that moment, the current equals the input voltage divided by the winding resistance. Once the rotor begins to spin, the windings generate back EMF, which offsets part of the voltage, so the current drops back to normal.
What about a brushless motor?
For a brushless motor, the reason for high inrush current is totally different. Its voltage cannot directly reach the windings because the electronic switches are off at startup. However, there is an electronic capacitor inside, which draws a shooting charging current instantly when powered down. Since the capacitor's internal resistance is very small, the charging current is large.
Can this current be reduced by design?
They can be reduced a bit in design, but the reduction is quite limited. For example, increasing the winding resistance of a brushless motor can reduce the startup current, as will sacrifice the motor's effective output power, so you have to find a balance. Same for the electronic capacitor. If you choose one with higher ESR, the charging current will be smaller, but the filtering performance will get worse.
So what should engineers keep in mind when integrating a water pump into
If it is a brushed model, you can use soft start by gradually increasing the PWM duty cycle, going from a low to a high duty cycle, so the current rises slowly as well. For a brushless motor controller, the charging current of the electronic capacitor is not controlled by the system, but usually the capacitor charges very quickly. So, if you design the MOSFET voltage and the current rating is higher, you can avoid issues. If the system has overcurrent protection, the overcurrent detection window can be extended to prevent a force triggering caused by capacitor inrush. Once the water pump is running normally, here is current 10. The higher the flow, the higher the current. The higher the head, the lower the current. The higher the speed, the higher the current. But this do not pose a problem because designers already test the temperature rate at the pump's max current to make sure the pump runs safely for long periods.